when the head reaches the point where the food is, let's make the food disappear and reappear elsewhere. We are regenerating the food or respawning the food. So let's create a function called eat food. Yeah, let's So in this function, we're going to test some conditions here. We're going to check if the head of the snake, its x and y coordinates are the same as the same coordinates of the food. If it matches, if it's true, we're going to have to regenerate the food and put it elsewhere. And how we're going to do that is, first let me just create the conditions. Okay, so now we're going to need a function called it's an object. It's called a random generator object. And what it does, first let's just declare it and initialize it. Okay, so what's happening here is we're using this random object, and when we want to say we want to generate any number, we give it this function next int. Now what this does is we gave it 40, meaning that what we're telling the computer is we wanted to generate any numbers from 0 to 39, but because we added this 1 here, we're saying instead of starting from 0 to 39, start from 1 to 40, meaning any number that pops out from this list, we should add it plus 1, so that instead of from 0 to 39 is 1 to 40, so 0 plus 1 is 1, and etc. So we give that to a temporary variable x and y for the food. So every single time the head eats the food, it regenerates and gives the food different coordinates, and it's random, so we don't know what coordinates it's going to give it. It's just going to randomize the numbers, and then we have to set it to the new variables of the food. So let's set Now we have to put this function in the trace and logic, and it needs to be before repaint. Every function we make should be before the repaint function, because the repaint function will be used to update all the changes we've made. In this case, the eat food function checks to see if the food has been eaten. If it does, then give it new coordinates. So we put that there, and let's see if the food will regenerate once we reach. Okay, it does regenerate. Okay, it looks like it gave it coordinates that are not in line with the squares. Okay, so we're supposed to be adding a 10 here, because, well, it's like this. What we're doing here is we're randomizing any number from 1 to 40, right? And because we're putting 40 here, you can put any number, but make sure that it is less than your width and your height, because what we're doing is whenever we get any number from, say, 1 to 20 or 40, we times it by 10. And when we do that is we get any number that falls under the squares that we created in our screen, the 10 by 10 pixel squares, and where they start. So 40 times 10 in this case is 400, right? Meaning that it's less than 500, which is an adequate number. You can add 20, 30, it's okay. It may be smaller, but I felt 40 is okay. So now once we do that, the food is going to always appear in the squares, in the boxes of squares that we have created for the screen. So let's see. Okay, so that's all well and good. Now we need to grow the snake. When we eat the food, the snake tail has to grow. First we need to create we have to create the tail first. Let me see. We're moving the head, we're checking if we're eating the food, and let's check if we can grow the tail. Let's grow the tail. Oh no, we're not going to grow the tail. We're just going to, because when we eat the food, we grow the tail. What we're going to do is we're going to follow the tail, not grow the tail. Let's make tails follow each other. Let's make the snake one whole entity by making all the segments or the blocks of the snake follow each other in this case, so that it looks like they're moving, they're part of one thing. So let's create follow snake, follow tail, I mean. Okay, so this is what we're doing with the follow tail function, is that, okay, so the head of the snake is the yellow box that you see in the screen, and the tail, we're going to give it a red color box, so we should differentiate between the two. So we don't need the head of the snake in this point. We're just going to need the tails, all the tails, the first starting tail all the way to the ending. So instead of, we don't want to start at 0, which is the head, we're just going to start at 1. So, and 1 going forwards. So we're going to check if it's greater than 0. Then what we're going to do is we're going to get what is it? The block or the segment of a previous tail, right? The tail that's after the one that we're going to use. In other words, let me just type and explain. So let me all right, so this is what we're doing right now. Let me just start from scratch. So we are looping through the whole snake at this point. The tail, which is going to always increment every time we eat the food. And I didn't edit here, I'm going to edit. So we're going to loop through the whole snake, and we're always going to start after the head. And we're going to always take the previous block of the snake that comes after the selected block here. So no, that comes before the selected block. So we're going to take the previous and set it. We're going to create it here, and then the current tail that we want to work with, we are going to set its previous x's and previous y's to the current, to its current x and y's, and then its set x and set y's, the new coordinates, we're going to give it the previous coordinates of the previous tail, so that every single tail that seems like it's following each other. It should always have the same x's and y axis of the tail that's before it, the one, you know, so that it looks like it's following the snake, it's moving with the snake. So let me just finish this up. Let me grow the tail, because after eating the food, we generate the food coordinates, we give it different coordinates, then we have to grow the tail of the snake. So let's grow it. Let me create a new object for the snake. We're first getting the old one, or should I say the current tail, which is going to be the old one in this case. Then we're going to set its we're going to take its previous axis and set it as the new axis of the new segment we're creating. So we grab it from our snake body array, Okay, so this is what's going on. We create a new tail once we eat a food, meaning the food will grow the snake will grow every time we eat the food. And we're going to take the new tail and give it its new x and y coordinates as the old, or should I say the previous axis of the current one, which is going to be the old one at this point. So let's put this follow tail function. Should we put it? Let's put it before eat food. Let's see if the snake will grow once we eat the food. It's growing, but it's not moving. Why? Alright, I think I need specs because I don't think I can see very well. I did a mistake that wasn't easy to identify because these things look almost alike. I added a 1 instead of an I. It's supposed to be I because the I is the 0. I thought it was an I, but I guess I put a 1. So look out for that mistake, and the snake, everything should be okay now. Okay, so now when we eat the food, the snake grows, which is cool. So let's now okay, so I see this is not a typical snake game behavior. We're not supposed to be going left and right across the tail. This is foul, and we'll need to adjust that. So how we do that is we go over to the key pressed function here, and then we have to check if we're moving from left to right, we're supposed to be checking the y-axis of the blocks of the snake, so that if they're in the same y-axis, then we should not be able to move left or right. The same case for the up and down, we check the x-axis as well. So let's deal with left and right first, and we don't have to check the whole snake at this point. We just check the head and the second part of the snake. It's going to give us a little bit of an error, which won't cost much, because whenever we start the game, it starts with one block of the snake, so it won't have any other block to check. So, but it's okay. We're just going to edit for now, and it will work. Now let's also do this for the right. So I'm just going to copy and paste there. It's okay, just to pass some time. And let's do this for down here. So we're going to change this to X instead of Y, because we're dealing with the up, down coordinates. Okay, let's check and see if we're able to move. Oh man, we're actually not even able to move at all. Why? Why? It's because I'm in a rush, and I need to put 1 here, not 0. Oh man, I need to really, it's not easy to type and talk at the same time. I realize that now. You know, this is my first video, so forgive me if I am being a little bit if I'm screwing up a little bit here. Okay, so as you can see, we're not able to go up or down. We're just able to go left, right, and center. I mean, not center, only left, right, up, and down. So that's what we want. So great, this is good. Now let's see if we try. Okay, so now we have to make the screen appear on the other side of our screen. I mean, the snake appear on the other side of the screen. If we're to cross the line here, cross the boundary, we need to keep the snake within our boundary. So whenever we move out of the screen, it appears on the other side of the screen. So I'm going to show you how to do that. Let me just come out. Okay, so let's create a a new function called follow tail. And it's no, not follow tail, cross line. It's going to be used to see if we've crossed the line. If we have, change our coordinates to then the next line so that we stay within the same boundary. So let's create this function. We're going to make a condition here. If statement, we're going to check if the head of our snake, at this point we just need to work with the head really. We're going to check if it goes out from the left, and if it does, it should appear on the end of our, if it goes out of our screen on the left, it should appear on the right. If it goes up, it should appear down. So let's make this condition. If head x equals to, if head x is less than 0, which is on our left side, then it should appear on the right side. So we're going to give it the coordinates of our width, at this case 500. We move over to y, we check if it's greater than 0. It's less than 0, meaning if it goes up, it should appear down. So we're going to give it screen height. And we always have to check for these silly mistakes. We have to give it the right axis, in this case the y-axis. Okay, let's add this cross line logic to our trace and logic. Crossing fingers, hopefully it works. Let's first eat the food. Okay, let me go up. Okay, it's working. Good. Let's try to go on the side, and it's appearing as well. So this is cool. Yeah, so we're actually making progress here. This is nice. Let's try to make, because the food, when it regenerates, even though it's random, what we don't want, a future error at this point is we wouldn't want the food regenerating anywhere where the snake is. It's not the laws of the snake game. In this case, it will just be game over. So what we want is, whenever we eat the food should always respawn at a location where the snake is not on, or any block where the snake tail or head isn't. So we have to check that condition. Let's create a condition called don't block tail, and we're going to check if the food are anywhere near, or the coordinates of the food that gets created is anywhere near the snake. If it is, then we regenerate it again until it's not. So let's create that function. We're going to make it a boolean, so it's going to return true or false. It's going to take two arguments. We're going to take the x and y's of the generated food, the new generated food. Then we're going to test it. We're going to test it with the whole snake at this point, the whole body of the snake. So let's create a for loop here. Okay, so this function, what it's going to do is it's going to check to see if the new generated x and y of the food matches any part of the tail, because it's going to go through this loop first, and if it does get any result at this point, it's just going to break through the loop and return true. If it doesn't, it's just going to return false, and then we can continue looping through the game. So let's add this first. Before, how we are going to use this is we're going to use a do while loop at this point. So whenever we check, whenever this is equal, whenever we eat the food, let's do this. Okay, so you remember that this function takes some parameters. What we have to do now is, let's set this here, because this is what we're going to use as our parameters, and then we'll give food. I'm not a fan of typing at all, so don't mind me copying and pasting. It makes the job faster. Okay, so what happens here is we're going to first do this, right? And check to see if this is true or false. Why is it giving me an error? Right, because you okay, so you have to declare them outside because we're creating an if function. So this if function is within a local scope, and we need to get the global scope of the eat food function. So we have to create it outside. It's okay. So now let's check and see. Okay, it's respawning. You cannot tell the difference now because things are so random, but I'm pretty sure it's not going to appear anywhere within the snake. So you are eliminating future errors here that isn't part of the snake game. So yeah, I think we are good to get to the next stage. Let me check. I think I like the snake when it's rounder. It makes it more, it makes it feel like it's moving, and makes it feel like you can see mostly what's going on if you just add some curves. So instead of fill rect, let's say fill oval. Fill oval. Okay, so you can feel like you can feel the different you can even see the different segments here instead of just having a whole square. At least now you understand how all these segments are coming together. Yeah, it's good. Now let's see, what else are we left with? Obstacles, maybe. We could increase the speed as well.